The addressing mode specifies how the processor accesses the data in memory. The x86 architecture implements immediate, direct, and indirect memory addressing. Indirect addressing can use a single register or two registers and a constant to calculate the final address. The addressing mode takes the names of the register used. In 32-bit mode, the choice of the register for addressing is much more flexible, and addressing is enhanced with the possibility of scaling, multiplying one register by a small constant. In 64-bit mode, addressing relative to the instruction pointer was added for easy relocation of programs in memory. In this video, we'll focus on the details of all addressing modes in modern 64-bit processors. You will see some examples that utilize the data copy instruction, which is named move in x64 assembler. The move instruction copies data from the source operand to the destination operand. In MASM assembler, the order of the operands in instructions is similar to that of high-level languages. The left operand is the destination, the right operand is the source. The immediate argument is a constant encoded as part of the instruction. This means that this value is encoded in a code section of the program and can't be modified during program execution. The size of the constant can be 8, 16 or 32 bits. The use of an immediate operand depends on the instruction. The move instruction copies the numerical constant value of 10 into the accumulator. Immediate value in other instructions can represent, for example, an offset of the address or additional displacement used for efficient address calculation. A value which specifies the number of iterations in shift instructions, a mask for choosing the elements of the vector to operate with, or a modifier which influences the instruction behavior. In the direct addressing mode, the data is reached by specifying the target address as a constant. The address can be specified in the instruction as a number, a previously defined constant, or a constant expression. This addressing mode is similar to variable addressing in high-level languages. In 64-bit processors, the default mode for direct addressing is relative to RIP register. In the instruction, the address is encoded as a 32-bit signed value. This value represents the distance between the data byte in memory and the address of the next instruction, so the current value of RIP. Such an approach enables encoding addresses in a smaller number of bits, namely 32 instead of 64, saving space in program memory. Additionally, it enables flexible placement of the program in the whole address space. In x64 architecture, there is a possibility to use one or two registers in one instruction to calculate the address. The final calculated address is called effective address. In the case of the use of two registers, one of them is called the base register and the second one is called the index register. In this architecture, any of the 16 general-purpose registers can be base register or index register, excluding the stack pointer. It can be the base register only. Additionally, the index register can be scaled by a factor of 1, 2, 4, or 8. In MASM, indirect addressing is marked with square brackets. Depending on the number of registers used in the instruction, the mode gets a different name. Let's go through the details. Base addressing mode uses the base addressing register only. In general, If there is one register used to specify the indirect address, it is the base register. In this mode, no additional displacement is added. Base register is not scaled. It can be interpreted as a pointer to the variable. Base addressing mode with displacement uses the base register and an additional constant. The final effective address is a sum of the content of the base register and this constant. It can be interpreted as the base register holds the address of the data table, and the constant is an offset of the byte in the table. A similar addressing mode is index addressing with displacement. Index addressing mode with displacement uses the index register with an additional constant added. So the final effective address is a sum of the content of the index register and the constant. It can be interpreted as the address of the data table is a constant, and the index register is an offset of the byte in a table. As you could note, currently the difference lies only in the interpretation. Different names come from the 16-bit architecture, where base registers were only BX and BP, and index registers were SI and DI. While two registers are used, we talk about base indexed addressing, or in other words, base addressing with indexing. In 64-bit processors, the first register used in the instruction is the base register, and the second one is the index register. Please notice two things. First, it is possible to use the same register as base and index in one instruction. Second, the stack pointer can be the base register only. In base indexed with displacement addressing mode, the combination of two registers with an additional constant is used. In 64-bit processors, any register can be the base, and all except the stack pointer can be the index. The constant is up to 32-bit signed value. The final effective address is the sum of the contents of two registers and the displacement. This mode can be interpreted as the constant is the address of the table of structures, the base register holds the offset of the structure in a table, and the index register keeps the offset of an element within the structure. As in base index addressing, in 64-bit processors, the first register used in the instruction is the base register, and the second is the index register. Almost all mentioned addressing modes can additionally use the scaling. Scaling can be applied to the index register only, enabling the multiplication of its content by 1, 2, 4, or 8. The most complex mode is base indexed addressing mode with displacement and scaling. It uses the sum of the base register, the content of the index register multiplied by a simple constant of 1, 2, 4, or 8, and an additional constant. The interpretation is similar to the base indexed addressing mode with displacement. The constant is the address of the beginning of the table of structures. The base register contains the offset of the structure, and the index register holds the scaled number of the element in a structure pointing to a chosen byte. This addressing mode is available for 32 or 64-bit processors and can use any general-purpose register as a base and almost any general-purpose register as an index except for the stack pointer. The displacement can be up to 32-bit signed value, even in 64-bit processors. Please note that scaling by 1 results in no scaling at all, so the base index addressing mode without scaling in real is the mode with a scaling factor equal to 1. The order of registers and the displacement constants in general is not important. The only exception is when two registers are used and neither is scaled. In this case, the first register is taken as base. Certainly, the stack pointer is never assumed to be the index. The sum operator is not obligatory. As shown in examples, the square brackets assume the addition operation by default. Summarizing, the schematic of the effective address calculation and use of register for indirect addressing in x64 architecture is shown in the figure. Any of the general purpose registers can be a base register, including new R8, R15 registers. The stack pointer can't be used as the index register. The index register is multiplied by 1, 2, 4, or 8. If present, the displacement is a constant of 8, 16, or 32 bits. The final effective address is a sum of all the mentioned elements.